Okay, good day everyone. Today we're going to discuss about inequalities. These are the topics that we are going to discuss. We have the linear inequalities, three-part inequality, quadratic inequalities, and rational inequalities. What are the properties that we need to remember in solving inequality? So we have the first one. If A is less than B, then A plus C is less than also to B plus C. You see that A is less than B. When you're going to add in both, we have side with the same value. Therefore, the result is still the same. We have A less than B. Second one, if A is less than B and if C is greater than 0. So therefore, we have AC is less than BC. And then if A is less than B, if C is less than 0. So therefore, it will give you now as AC greater than BC. So from there, you can replace less than with greater than, less than or equal, or greater than or equal. Result is similar properties. In motion problems, okay? So when you're going to multiply or you're going to divide by a negative number, because in each variable there is a coefficient there. So we have, if you're going to multiply and divide by a negative, the direction of the inequality will be reversed, okay? So let's show that one in some of the examples. So a linear inequality now in one variable is an inequality that can be written in the form of ax plus b, okay, less than 0, where a and b are real numbers with a is not equal to 0. So any symbols we can use, we have the greater than or equal, less than or equal, or we have the greater than. Let's try this first example. First example says that we have solved for negative 3x plus 5 greater than negative 7. First thing you will do is you have to simplify this value, which is the constant value here, which is 5. So simplify that one. You have to subtract both sides by 5, or you can move as well 5 on the other side, which is from positive becomes negative 5. So that is the same. So we have negative 3x plus 5 minus 5 greater than negative 7 minus 5. So we will have now 3x, okay, negative 3x greater than negative 12, which is x. You change now here. You can observe, right? When we are going to divide and multiply, okay, when you're going to divide and multiply a negative value, therefore, the direction of the inequality will be reversed, will be changed. So from we have greater than, it will become now less than. Therefore, your answer here will be x is 12 divided by 3, or negative divided by negative becomes positive. So x is less than positive 4. Okay? So don't forget to reverse the symbol when you're going to divide a negative value. What are the type of intervals? Set, interval notation, and then the graph. So if it is open interval, you can observe that the x is greater than, okay, x is greater than a. The interval notation will be open parenthesis, a going to, we have infinity, positive infinity, and then close parenthesis. So here in the graph, it will be from a. All the solutions will be from a going to positive infinity. And then if it is x is greater than a, x is less than b. So therefore, all the values now are inside a and b, between a and b. So your interval notation will be a and b. Open and close, we have parentheses. If it is x less than b, so therefore you will have now negative infinity, because the solutions is from b going to negative infinity. So you will start from negative infinity going to b. So your solution now, your graph will be from b going to negative infinity. The other intervals are x is greater than or less than or greater than or equal to a. So therefore, it will be a bracket. That is the difference now between a bracket and a parenthesis. If it is only greater than, it will give you a parenthesis. If it is bracket, you will have now bracket a going to positive infinity. So a is also a solution here. A is included as a solution. So therefore, x is greater than or equal. So x is equal to a as well. And x will be greater than a. So therefore, your possible solutions now is from a going to positive infinity. The other one, we have x is greater than a and x is less than or equal to b. So the solution is between a now going to b, but b is also part of the solution and a is not. So your interval notation will be parenthesis and a bracket. The other way, we have x is greater than or equal to a and then x is less than b. So here, therefore, the parenthesis will be here, the brackets will be here. Brackets a and parenthesis b, right? B and parenthesis. So your solution will be the opposite of the second one, which is now the bracket and then the parenthesis. And then x is less than or equal to b. So therefore, your solution set now is from negative infinity going to, we have positive b, which is the bracket here. So the graph will be from b going to, we have positive or negative infinity. There are other intervals. We have the closed interval, which is your solution is enclosed between a to b. So the solutions there is a going to b. So your interval will be a, bracket a, b, bracket b. And then the disjoint, in mathematical symbol, we have the mathematical symbol u here, which is negative infinity a or b going to positive infinity, because there are two possible solutions. We have the a going to negative infinity and b going to positive infinity. That is how you will solve for the disjoint interval. How about if all your answers, all the values are x, are real numbers? So therefore, you just write from negative infinity going to positive infinity. Okay, so let's try this example. We have solved for 4 minus 3x less than or equal to 7 plus 2x. Give the solution set in interval notation and graph it. So be careful in solving the solution set, because if you're getting mistake with the solution set, your interval will be wrong and then your graph will be wrong as well. So therefore, what is that one? So first, simplify 4. Okay, so we have the value 4 here. You have to simplify first that one, which is you have to subtract 4. So therefore, the remaining now will be, this one is negative 3x, right? Because negative is here, so negative 3x less than or equal to 3 plus 2x. To simplify 2x, we are going to subtract by 2x both sides. So here, negative 3x and negative 2x will become negative 5x, okay? Less than or equal to 3. Then after that, your possible answers now will be x is greater than or equal to negative 3 over 5. Okay? So because we are going to divide both sides by negative, therefore the sign, okay, the direction of our inequality now will be changed from, we have less than becomes greater than or equal. And then after that, what is the graph? So the graph will be this way. So from negative 3 over 5 going to positive infinity. What is our interval notation? Our interval notation is from, okay, interval notation set now is from 3 over 5 or bracket 3 over 5 going to positive infinity. If it is infinity, it will always be parentheses. Next example. How about if we are going to solving a 3-part inequality, which is this part, negative 2 less than 5 plus 3x and 5 plus 3x, okay, 5 plus 3x less than 20. So first thing you will do is simplify 5 with the variable. So therefore, we are going to subtract both sides by 5. So now, the result will be negative 7 less than 3x less than 15. And then after that, you're going to divide now by positive 3. This one, we divide by positive 3, so therefore there will be no changes with the direction of the inequality. So therefore your answer now will be negative 7 over 3, okay, negative 7 over 3 less than x less than 5. So your solution set now will be, the interval is from negative 7 over 3 going to 5. Now let's go to quadratic inequalities. In solving quadratic inequalities, we have the same in solving quadratic equation. You can use completing the square, you can use factoring, or you can use, we have the quadratic equation. Okay, so you have three methods. You have to choose which method are you going to use, which is easier for you. A quadratic inequality is an inequality that can be written in the form of ax squared plus bx plus c less than 0, where a and b, okay, are all real numbers, and a will not be equal to 0. Okay, so we can replace, it will be greater than, it will be less than, or it will be less than or equal, or greater than or equal. Okay, so the steps or the methods, we have step 1, solve the corresponding quadratic equation. Then after that, we're going to identify the intervals between, determined by the solutions of the equations. Then use a test value from each interval to determine which intervals form the solution set. Okay. Next, let's try example number 5, which says that x squared minus x minus 12. From here, you're going to find first the values of x, which is we use by factoring, or you can use by quadratic equation. But here we will try to use, we have factor. We can factor it out, right? We have x minus 4 and x plus 3. Okay, so therefore these are the values of our equation. So we have now x plus 3 equals 0, or x minus 3 equals 0. Therefore our solution are, we have x minus 3 and x equals to 4. What we are going to do next? Next is you are going to find the solution set, or the solution intervals. What are the intervals from this one? These are the intervals. We have interval A, interval B, and interval C. Our answer is negative 3 and 4. So therefore we have three different intervals, from negative infinity going to negative 3, negative 3 going to 4, and 4 going to positive infinity. These intervals, we need to check if it will define our equation. Okay, so therefore we are going to use some values between the intervals if it will define our equation. For example, when we are going to test the values now, okay, so we'll move this way. When you're going to set the intervals, okay, so or set the test values, you're going to choose from negative infinity to negative 3. Okay, so therefore we choose negative 4. It says here, negative 4 will not define our equation because it says 8 is less than 0. But the next one, negative 3 to 4, we choose 0, which is 0 will give us negative 12 less than 0, which is true, right? And then for the interval C, we have now 5, and then it is also false. So therefore here, the solution for this equation, the interval B. So since the values in interval B make the inequality true, therefore your solution set now is negative 3 and positive 4. Okay, is there two intervals, or is there a solution, or is there an equation that will give two intervals? Let's check some of the example. Let's try, we have 2x squared plus 5x minus 12 greater than or equal to 0. Okay, let's jump off to what is the factor of 2x squared plus 5x minus 12 equal to 0. So therefore it will give us 2x minus 3 and x plus 4. So your answers now will give us 2x minus 3 equal to 0 and 2x plus 4 equal to 0. So zero factor property. And then after that, x now is equals to 3 over 2 and x equals to negative 4. What are, the next step is, what are the intervals? Okay, so the intervals here now is from negative 4 or negative infinity to negative 4, and then negative 4 to 3 over 2 and 3 over 2 going to positive infinity. Okay, so these are the intervals. And then after determining the intervals, you have to choose again the test values. What are the values that you're going to choose between negative infinity to negative 4? Negative 4 going to 3 over 2 and 3 over 2 going to positive infinity. So therefore, we have these test values. We have negative 5, 0, and 2. Upon we have checking the given test values, we have the result here. It says that from negative 5, it will give you the definition. But here in 0, it says it false. And then in 2, it is also true. So therefore, you have two possible intervals. The set of intervals now, the answer for that one, the solution set, is united with negative infinity and negative 4, or 3 over 2 to positive, we have infinity. And then observe that it is in bracket form. Why? Because we have now as greater than or equal. Okay, so therefore you have to check every time if it is parentheses or we have brackets. Okay, but if it is in infinity, it will be always give you a parentheses. Okay, so inequalities that use the symbols we have less than, greater than are called strict inequalities. But if it is less than or equal, greater than or equal, it is used as non-strict. We have inequalities. The solutions of the equation in example 5 were not included in the solution set since the equality was strict inequality, right? So in example 6, the solution of the inequality were included in the solution set because of the non-strict inequality. You have to consider only the parentheses and then the brackets. If it is strict, just only we have parentheses, and then if it is non-strict, it will give you a bracket solution. So there are some problems related with inequalities. So for example here, if a projectile is launched from the ground level with an initial velocity of 90 feet per second, its height in feet t seconds after launching is s feet, where s equals to negative 16t squared plus 96t. Where will or when will be the projectile be greater than 80 feet above the ground level? So in applying the inequality, we can have now as x 16t squared plus 90t greater than, because it will be back there, greater than 80 feet, right? So therefore we have this equation, and then equate to 0. It will give us, we have this equation, and then we divide everything by 16, okay? Because all of them are divisible by 16, negative 16, so we change that one into t squared minus 60 plus 5, okay? Less than 0. Why we change this one into less than? Because we divide everything by negative 16. So therefore, we can solve now what will be the corresponding equation, right? From there, we can factor out t minus 5 and t minus 5 and t minus 1, which is now the t is 1 and t and 5. So you can have now the interval. After that, the interval will be negative infinity to 1, 1 to 5, and 5 to positive infinity. And then do the checking. Use the procedure of example 5 and 6, right? The past example that we give to determine that values in interval b, 1 and 5 satisfies the inequality. The projectile is greater than 80 feet above ground level between 1 and 5 seconds after it will launch. So try to check that one using the values here in the intervals, and then you can check your solutions. Now let's proceed to the last one, which is the rational inequality. Rewrite the inequality first if necessary, so that 0 is on one side and there is a single fraction on the other side. Next, determine the values that will cause either the numerator or denominator of the rational expression to equal to 0. So always remember, if it is rational form, if it is 0, there will be no possible solutions to that one, right? Those values determine the intervals of the number line to consider. Use a test value again, and then from each interval to determine which intervals form from the set. A value causing the denominator to equal to 0 will never be included in the solution set. If the equality is strict, any causing the numerator to equal to 0 will be excluded. If non-strict, any such value will be included. Okay? So we will explain that one further in some of the examples. So from here, we have solving a rational equality such as 5 over x plus 4 greater than or equal to 1. By multiplying both sides, okay, both sides by x plus 4, okay, x plus 4 to obtain now 5 greater than or equal to, we have x plus 4 requires considering two cases. Since the sign of x plus 4 depends on the value of x, if x plus 4 were negative, then the inequality symbol must be reversed. But if it is positive, it will remain the same. Okay? So therefore, you will have now x, okay, 5 over x plus 4 greater than or equal to 1. We can have now simplify minus 1, right? So therefore, we can get as x plus 4 over x plus 4. Therefore, next one. Okay, you can have 5 minus x plus 4 over x plus 4 greater than or equal to 0. And then after that, we get x minus or 1 minus x, because we have here 5 minus 4, okay, becomes 1 and then negative x. So therefore, we get 1 minus x, okay. Careful of the parentheses, okay? Be careful of that one. And then combine like terms afterwards. So therefore, the step 2 now, possible changes of sign only where x values make the numerator equal to 0, right? This occurs at 1 minus x equals to 0 and x plus 4 equals to 0. So therefore, we have x1 or x negative, we have 4. If you are going to substitute now the value of x there, the numerator will become 0. So let's check which one will define our solution. So these are the intervals, right? So the intervals is from negative infinity going to negative 4. Where did we get 1? Back in the solution. Because our solution set is x equals 1 and x equals to negative 4. How did we get that? Because our equation now will give us 1 minus x over x plus 4 greater than or equal to 0. So we have two possible solutions now. We get that 1 minus x equals 0 and x plus 4 equal to 0. So therefore, we have 1 and negative 4. That is how we determine now our intervals. After determining the intervals, you have to check now with the test values. The test values are, we have choose test values. So we have to choose between negative infinity to negative 4, negative 4 to 1, 1 to positive infinity. It says here that in testing all the values between A, B, and C, only one will define the solution, which is the interval between negative 4 going to 1. Therefore, this one is true. Okay, so therefore your test values now, okay, your answer now, we have the values in the interval negative 4 and 1 satisfies the original inequality, right? The value 1 makes the non-strict inequality true, okay? So therefore, if you're going to put 1 there, if you check 1, it says that it will makes the non-strict inequality true, okay? So it must be included in the solution. Because if we will put 1 there, 1, okay, the original equation, 1, okay, so that will be equal 5 over 1 plus 4 equals 5 as well. 5 over 5 is equals to 1. So 1 is greater than or equal to 1, so that is true. So therefore, 1 is included. But negative 4, Okay, negative 4 will be excluded because it will make the denominator equal to 0. Because if you will put in the value of x here equals negative 4, the equation now will become 0. That's the reason why negative 4 is excluded. So your solution set will be parenthesis negative 4 and bracket 1. Okay, so again, negative 4 is not included because it will give the solution set equal to 0, right? And then 0 is not equal or greater than 1. Therefore, negative 4 is excluded. So as suggested by example in 8, be careful with the endpoints of the intervals when solving rational inequalities. Okay, next example. What if we have 2x minus 1 over 3x plus 4 over, or 2x minus 1 over 3x plus 4 less than 5? How will we solve the equation? Okay, first thing, you will do equate to 0. So therefore, you will have 2x minus 4 over 3x plus 4 minus 5 less than 0. Next, subtract. So you have to make it the same denominator. So we multiply both sides by, or we multiply 5 now by 3x plus 4. Then after that, simplify. So we simplify now 2x minus 1 minus 5 times x. Okay, so with one denominator only, we have 3x plus 4. And then after that, simplify now the equation. So we can write now as 2x minus 1 minus 15x minus 20 over 3x plus 4, okay, greater than 0. And then after that, simplify more further. So therefore, we will have negative 13x minus 21 over 3x plus 4. So we solve now for the values of x. With these two, we have problems or given equation. Therefore, your equation now will be negative 13x minus 21 equals 0 and 3x plus 4. So we get negative 21 over 3 and 4 over negative 4 over 3. So these are the intervals between negative infinity to negative 21 over 3, negative 21 over 13 to negative 4 over 3, and 4 over 3 going to positive infinity. After determining the intervals, you have to check now with the test values. Okay. Now choose the intervals and verify that negative 2 from interval A, okay, makes the inequality true. 1.5, so you have to check. This one is just only a shortcut way. So by checking, it says that A is true, B is false, and C is true as well. So therefore, we have two possible solutions. It will give us, okay, negative infinity, negative 21 over 3, but the symbol is less than. So therefore, you will use, we have parentheses. Okay, so the same, because C is true as well. So therefore, your solution will be parentheses negative 4 over 3 going to inequality. Or we have the inequality answers there is going to, we have infinity. Okay, positive infinity. Okay, so in solving rational inequality, please be careful with the sign. Please be careful with the symbols as well. How to use, we have the symbols in the last solution set. Okay, so there are some problems that we need to practice more, and then that problem, if it will requires you to divide a negative and a positive value, you know already how to do, or when the times you will reverse the direction of inequality. If you have questions and clarifications, you can email and send me a message. Thank you and have a nice day, everyone.